Identifying which type of metal is most resistant to corrosion when exposed to milk. Purpose. The purpose of my project is to determine which type of steel, plain, galvanized, or steel is most resistant from corrosion due to milk. Research. One of the main problems with the use of steel in agricultural, industrial, and food and beverage applications is the rusting of metal. When steel is exposed to rainwater or water dissolved in the liquid, the oxygen rusts the steel. Two types of steel were invented to increase corrosion resistance. Hot-dip galvanizing steel is with a special zinc coating. Stainless steel is an alloy of steel and chromium. Trucking tankers, storage tanks, and processing of piping milk and processing sites are critical for economic processing, distribution, and sale of milk for between $2 to $4 a gallon. Even though they contribute to the economics, safety is key. If the steel in these pipes, tanks, and trucks is constantly exposed to milk, then they need to be corrosion resistant so that the trace of quantities of metal cannot enter the food supply. In 2019, the U.S. produced more than 218.3 billion pounds of milk, and all this milk must be harvested, stored, transported, and pasteurized. It is critical that we ensure that the metal the milk is exposed to is corrosion resistant. I hypothesized that if the three types of steel are exposed to milk, then the galvanized steel will exhibit the least amount of corrosion. Materials. Below are the materials that are used in this research. Procedure. In order to complete the experiment, after the 6 mason jars were labeled, I measured the weight of two sets of 10 of the 3 steel types of steel washers. Then I placed the washers into their respective jars: 3 experimental milk steel, milk stainless, milk galvanized, 3 control air steel, air stainless, air galvanized. Then for each of the 10 days, I removed the washers, wiped and dried them, recorded the mass, and put them back into the jars. Chart. Pictures. Below are the pictures that are used in the experiment. Charts and graphs. Graph 1, the average mass for the 3 types of steel. Graph 1 depicts the average mass data for the 3 types of steel in both experimental and controlled conditions. Graph 2, percent changes in mass for 3 types of steel. Graph 2 provides the mass data for the air control group across the 10 days in the experimental group. It depicts a percentage change in the mass using grams for the 3 types of steel. Conclusion. The hypothesis is not supported because stainless steel, not galvanized steel, had the least amount of corrosion. The control air group corroded less than the milk, which corresponds with the research that steel corrodes more in liquid environments. Interestingly, galvanized steel had roughly the same amount of corrosion as steel, which means that zinc coating could be chemically reacting with a component in the milk. Applications. The research has major implications for the multi-billion-dollar food and beverage industry. Engineers who design tanks, trucks, and process piping that physically touches milk should try to use stainless steel instead of steel or galvanized steel. This will help increase the safety of milk, which is a key requirement of the FDA, which regulates this industry. Limitations. This research could have been conducted in a climate-controlled laboratory setting due to reduced impact due to variation in atmospheric conditions. However, all the 6 jars were placed close to each other, which helped mitigate this. The clouding of milk also needs to be looked in for improved results. Views of research. In the future, research on corrosion in milk needs to be conducted with more types of alloy steel like mono and Inconel. Using larger steel objects is another way to further understand the interaction between milk and metal. I plan on working this within the future to dive into this interesting field more. Thank you. This is Different Canyon.